So let's talk about this question. Part A and B of this question. This is just it's a classic kind of question that we've got here where they've told us about the distance here, the distance here. They tell us something during the question that it reaches a maximum point of 10 meters, a maximum height from its starting point. But they don't tell us anything about the initial speed. They don't tell us the angle, and they don't tell us the speed. Your instinct might be to name this as, I don't know, u cos alpha, and u sine alpha. But what happens is you get a question that is just unnecessarily filled with sine alphas and cos alphas because we don't ever want to find out what alpha actually is. And even if we did want to find out what alpha actually was, if I just find out what x and y are, well, you come up with a triangle where you would know this value and this value. You could then find out what the speed was by doing Pythagoras, and you could find out what the angle was by doing trigonometry. So I would not recommend naming these things u sine alpha and u cos alpha because they're not interested in the angle in this question. They haven't told us the angle or anything like that either, okay? So all we do for this first part of the question is it said something that the stone rises to a maximum height of 10 meters above the level of O. So I did a bit of suvat here using y as my initial speed, negative acceleration, positive displacement, and I knew that the vertical speed was 0 because when it gets to the top of that peak, it will have no vertical speed. That shows that y was 14. The second part of the question, which wanted to find the speed of projection, well, we already knew that the y part of the projection was 14. So really the question is saying, find the x part of the projection. But to find the x part of the projection, we need to find out how long the whole journey takes so I can work out how fast it was traveling in this direction for the same amount of time. So I do suvat up here to find out how long it takes to reach the ground. Notice how these are my positive values because it's going downwards and that u is negative because it's going upwards. That's the u that we found earlier on. And that told me it was 5 seconds. Obviously, I'm not going to have a negative time here. Horizontally, using speed equals distance over time, I found out that the speed it was traveling at horizontally was 10. So it was 10 across and 14 up. Just do Pythagoras to take those two separate times and those two separate speeds and put them back together as 17.2. But this is where the question got interesting in part C. It said, find the time after projection when the stone is moving parallel to OB. Well, every tangent to this curve, if you drew a tangent to the curve, that is actually the direction that the stone is moving in. So at the top here, this diagram is going to get pretty complicated, but if I drew a tangent there, at the very top of it, it is just moving horizontally, which makes sense because there's no vertical speed. So this question is trying to say, when is the stone moving parallel to OB? In other words, at what point on this journey is this tangent line going to be the same as this direction line that we've got here? Now, there are obviously many ways of thinking about this. One of the ways of thinking about this could be to do with gradient. We could think about what's the gradient of this line and try and make these things have the same gradient as well. I thought about it using similar triangles. You could have thought about it using angles. You could have said, okay, well, if this angle here is theta, I want this angle here to also be theta, and you could have done stuff with tan theta as well. But they're all the same thing, because tan theta is just a measurement of this side and this side. Gradient is just a measurement of this side and this side. And my method of similar triangles is also just a method, is also just a way of comparing those two sides together, okay? So if I show you the way that I looked at part C, this is a diagram that represents the journey from the start point to the point of the floor. And this is I want this direction to be parallel for the stone. It's going 50 meters across and 52.5 down. Masuma said, oh, well, I could work out the gradient. I could do 52.5 divided by 50. So I'm just going to quickly put that in a separate box because could do that. You could say it's 52.5 divided by 50. And then we know for this one, it's got to be the same thing. It's got to be the same gradient because the horizontal speed can't change. The horizontal speed has got to be 10 because it can't change. And the vertical speed is the thing that we're interested in. If I find out what the vertical speed is, the question is solved. I just use a bit of suvat to find out what it is. Now, Masuma's method, I could work out the gradient by doing the change in y divided by the change in x. So I get v divided by 10. When I multiply this all around, I would get that v is equal to 10.5. This is doing it as like a gradient kind of method. The way I saw it is that these lines here would be parallel if they are similar triangles. The angles would all be the same. And I noticed that 10 is multiplied by 5 to get 50. So if I want to find out what that side is, I just divide it by 5. And it's exactly the same maths that we've got over here, just seeing it in a different kind of way. So what we discover is this value of v needs to be 10.5. So I do another set of Suvat where I'm saying the speed downwards is 10.5, the acceleration downwards is 9.8. Its projection was 14 up. Do v equals u plus at, and you end up that t equals 2.5. Yes, Hamza?
How come you can compare the distances to the speed?
Because I'm not comparing the distances to the speed. I'm comparing the direction of the distance OB to the direction of the speed. I'm actually comparing the ratios of the sides. I'm comparing the parallelness of them.
Oh, and then it will give the same gradient, basically.
It gives the same gradient, yeah. So this bit over here was what Masuma was talking about with gradient. This was me talking about similar triangles. Equally, what you could have done is said, okay, well, I'm going to find out what this angle theta is by doing the inverse tan of 52.5 over 50. And you could have done the same thing over here and knew that tan theta was v over 10, and you could have solved it in that kind of way as well. You would end up with exactly the same idea of this sense of being parallel. Okay, so if something is traveling parallel, you have to think carefully about, well, this one is fixed. What can I change this one here to as something that's a bit different? Okay, we've got just enough time to kind of finish this topic off because I want to be able to send you with lots of practice on these kinds of questions because it's a 2-lesson topic, but guaranteed, well, I would say like 90%, there will be an exam question on this in your mechanics exam. I think there's usually about 5 or 6 questions. There will be a projections one and probably not a Suvat one from year 12 because this overtakes year 12 Suvat, clearly. You're doing Suvat all the time and you're doing it in a much more complicated kind of way. So this is a hugely important topic. Just because I've spent 2 lessons on it doesn't mean it's unlikely to come up. It is incredibly likely to be in your exam. So we'll just do the last part of this, which I don't think there's anything new to learn here. It's just about seeing that there are some projectile formulae that we can come up with. You may be asked, nothing new here, but you may be asked to prove more general results regarding projectile motion. And this is where they like to pull in a bit more of your understanding of trig and things as well. So let's just dive in with a question. It's the best way to teach this bit. A particle is projected from a point on a horizontal plane. As soon as I've got that, I'm just going to draw my horizontal plane with an initial velocity u at an angle alpha above the horizontal. And it moves freely under gravity until it hits the plane at a point B. Given that the acceleration due to gravity is g, not 9.8, because we could be on the moon here, find expressions for the time of flight and the range of the horizontal plane. The time of flight is the time it takes for it to go from here to here. The range is the distance from here to here. So everything is unknown. There are no numbers in this question at all. But we're going to just proceed as though there were numbers, okay? We will split this into our usuals, into our u cos alpha and our u sine alpha. And then we're going to just proceed as normal. If I was going to ask you to find the time of flight here, do you think that we would use the vertical or the horizontal? We would use the vertical. We're going to use the vertical motion. I don't mind if we use up or down. I personally, I don't know why, I would just go with up, just because I feel like it's being projected upwards. Now, do you remember last lesson when we talked about time of flight and people said, oh, well, I would just work out the time to the top and then I would double it. This is going to be an instance where it's better to use my method because you don't have to do any more maths with lots of complicated variables. You will have one equation, done, okay? So for this vertical motion, we can clearly see that its initial speed is u sine alpha, and we know that the acceleration is minus g, because remember we're taking upwards as positive. S is 0. If you take a picture of it at the beginning, you take a picture of it at the end, you would be like, it doesn't look like it's moved anywhere. It's still vertically on the floor, so there is no displacement at all. And we're interested to find out what is the time of flight that we've got here. Oh, and it says actually the time of flight is equal to capital T. Yes, Sadia?
Why is S equal to 0?
Because the displacement from here to here in a vertical direction is no movement at all. Vertically, it's on the ground, it's on the ground. Okay, displacement is not the distance that it's travelled. Okay, remember displacement is, it could have gone anywhere at all. As long as it ended up here, it hasn't displaced vertically. Okay, so putting these things together, we just get, using S equals ut, same old, plus a half at squared, 0 equals u sine alpha multiplied by t plus a half g t squared. So the time of flight, we get ut sine alpha plus, I'm just putting that t in the right place. So we're going to factorize this. So you get u sine alpha plus a half gt. See what I've done with the factorizing? Just pulled the t out. Now either this tells me, yeah?
What happens to the minus G?
Oh, it should have been minus g. Thank you. Thank you. So this should have been minus a half. If anyone else was thinking that and didn't say it, shame on you. Thank you, Anika. So it should have been negative there. So either t is equal to 0. That's the one that's just not interesting, because we know at 0 there is no displacement. But now the other thing that we've got here is u sine alpha minus a half gt is equal to 0. So just putting that to the other side, well, we get u sine alpha equals a half gt. So multiply by 2 and divide by g, and you get what the time of flight is.
You get the formula sheet.
Nope, you don't need to memorize this. So what you'll notice I've written at the top is you may be asked to prove these results.
What's in the back end of this?
So you need to know how to be able to prove these things, but I wouldn't expect, it would be ridiculous to go into the exam and be like, oh, time of flight, great, it's just 2u sine alpha over g. Like, who's going to remember that when you've got a million things you're memorizing for your A-levels? No one's going to remember that for part A. Now, part B of the question wants us to find the range on the horizontal plane. Okay, so range, let's consider the horizontal motion. Speed is u cos alpha. Distance is the thing that I'm looking for, r. And the time is 2u over g sine alpha. Speed times time. So if I want to find out the distance is equal to u cos alpha multiplied by 2u over g sine alpha. And I want to simplify this. So I have 2u squared over g sine alpha cos alpha.
You can put the 2 sine alpha cos alpha as a double angle.
Good. The 2 sine alpha cos alpha becomes just
sine 2 alpha.
sine 2 alpha. So you get u squared over g sine 2 alpha. So just a reminder of what we did here that Rayhan said. The 2 sine alpha cos alpha is the same as 2 sine alpha. And if you don't know that by now, I'm furious. Because the amount of times I've said to you that you need to know these formulae for double angle formula, they just pop up everywhere. Who would have thought it, like when you first have your first lessons on mechanics in year 12, that you'll be doing that kind of trigonometric stuff. You just don't expect it, okay? So that's the formula for the range. This is probably useful if you were building a computer program, or if you were taking in lots of data and you wanted to do an experiment. This is why you might come up with this. You might be trying different experiments where you're doing lots of different values of u, lots of different angles of projection. Much better to have this than to keep having to do the same calculations again and again and again. Much more simple to just have one formula. But you won't need to memorize this, but you may need to prove this in the exam, okay? Have I got just one more question to do on this, or is it two? Okay. So we'll do another one here. Particle is projected from a point with speed u at an angle of elevation alpha and moves freely under gravity. When the particle is moved a horizontal distance x, its height above the point of projection is y. Show that y equals this. X tan alpha minus gx squared over 2u squared, 1 plus tan squared alpha. When you see 1 plus tan squared alpha, what do you think of?
Sec squared.
Well done. Good. I'm imagining, I might be wrong, but if sec squared alpha comes up, or 1 over cos squared alpha, we know we can rewrite it in the way that they want it there. This is why you need to be familiar with these things. So a little diagram, because there's not an awful lot to think about here. We have u, we have alpha, and we are trying to find out the y component for a particular x component. They've said when the particle has moved a horizontal distance x, we want to find out what the y part is that we've got there. Yeah, Ibrahim?
How do you know that's horizontal plane?
Oh, well, it doesn't matter if it's on a horizontal plane. It doesn't matter if it was here and it went all the way down here. Because as long as they tell me what the x distance is, this formula will tell me what the y distance is. It will give me a negative. So it doesn't matter if it's on a horizontal plane or not. We're trying to keep this as general as possible, right? Okay, so we've got our u cos alpha and our u sine alpha. I'm running out of space, so I might need to do that in a different colour. Which one's going to be best to start with, horizontal or vertical?
Vertical.
It's a 50-50 guess, and I would go horizontal here because we're trying to show what y is equal to. So I'm not going to be able to show what y is equal to unless I know what x is equal to, or something in terms of x. So we are going to start off by thinking horizontally and just seeing what we've got. Now, the distance that we think it's going to go horizontally is what? Is x, and the speed is u cos alpha. Do we know what the time is? Good, because we need t. T is the bridge value that will take you in between horizontal and vertical. So t is the thing I'm going to use here. I'm going to find out what the time is, and then I can put that into the other equation. So time equals distance over speed. I'm already interested in the fact that I've got over cos alpha, which is a sec alpha, which I'm hoping at some point is going to be squared and give me this little result up here. So you can start, the more maths you do, and obviously I've been doing it for years and years and years, you can start to spot these things. So vertically, let's consider upwards as positive. Why not? We know that its initial projection is u sine alpha. Tell me some other things that we know about here.
We know that time is
A is minus
x over u cos alpha.
Okay, we know that the time is x over u cos alpha because we're immediately going straight in with our simultaneous equation here. Someone else said something.
A is minus 9.
A is minus g because we're trying to keep it as general as possible. And what else? And s is equal to y. The displacement is y. So it's weird. As long as you understood everything you were doing with numbers, it's just the same. It's just all algebra. And we are going to connect those together using s equals ut plus a half at squared. So y is equal to u sine alpha multiplied by t, which is x over u cos alpha, plus a half times minus g times t squared, which is x squared over u squared cos squared alpha. And there it is.
Simplify to that.
That's going to simplify to that. So we get y equals, well, the u's cancel. The sine alpha over cos alpha becomes, so you get x tan alpha. You then get here minus, on the numerator, you have g x squared. On the denominator, you have 2, and you have u squared. And we also have the 1 over cos squared, which we said is sec squared which we said is 1 plus tan squared alpha. Why do you think that they changed the sec squared to 1 plus tan squared? Just from, because then everything is in terms of tan. Because then if you work out what tan alpha is, then they often give you tan alpha. You can then just work out what the whole thing is by just subbing in loads and loads of values. Yeah, Ismail. You sure? So that was part A, and then part B just becomes a substituting in kind of question. Mizuki, you okay there? No? Okay. I'll see you after school. I'll spend some time with you and we'll go through it then, okay? So they've now got, it's projected from O, horizontal plane. So now they're telling us it's a horizontal plane, Ibrahim. Speed is 28 at an angle of elevation alpha. It passes through a point B, which is a horizontal distance of 32 and a vertical distance of 8 meters above. So that's telling me that X is 32 and Y is 8, correct?
Yeah.
And I just want to find out the two possible values of alpha, giving my answer to the nearest degree. So I'm just going to do a substitution question. We're just going to get 8 equals 32 tan alpha minus 32 squared times 9.8 over 2 times 28 squared, 1 plus tan squared alpha. What type of equation is this? It's a quadratic in tan, isn't it? So I better work out some of these bits. Looks like it's going to be a pseudo-quadratic, so I get 32 tan alpha. Now this thing here, 32 squared times 9.8 divided by 2 times 28 squared is very generously 32 over 5, which is just ideal. So you get 32 over 5 multiplied by 1 multiplied by tan squared alpha. So all I did, that's 32 over 5. I expanded it by multiplying it by 1, and I expanded it by multiplying by tan squared alpha that I've got here. Probably you can spot that there's some common kind of factors here.
Minus 72 over 5.
So let's just make it a quadratic. Let's save a bit of time. So we've got minus 32 over 5 tan squared alpha plus 32 tan alpha
Minus 72 over 5.
minus 72 over 5. So it's a quadratic. Who wants to do it? Who's going to tell me what the two values of tan alpha are?
You're welcome.
And then we'll stop after this.
And this
Second degree, so we got minus 32 over 5. We then have 32, and we then have minus 32 over 5. And 9 over 2 and a half.
9 over 2 and a half. Okay, so alpha is the inverse tan
That's for when you do graphs.
of 9 over 2.
Why is that? That's 2.
So alpha is 77.5 degrees, or alpha is the inverse tan of a half, which is 26.6 degrees. So there are two possible angles. Now, when you solve trig, you should always try and find out the other values. But if you added 180 to this, you can't project a particle at that angle. If you took 180 away from this, you can't really do that either. So these are the two that make sense. Now, what this is actually looking like is we have said we wanted it to be at a point that was 32 meters across and 8 meters up. We're saying, when is it going to hit that particular point? And there's two ways you can do it. You can either go like this, like that, where the angle was 77.5, or you could go like that, where the angle was 26.6. So that's why there's two answers for this, because there are two scenarios that have the same speed, because they have to have the same speed in this situation. They have to have a speed of 28. You could either, if you wanted to hit a particular target, you could either throw it up at a really big angle or a narrow angle. Yes?
How do you know that it hits at the end of the jump, not at the start of the jump? Like, you know, if it goes across and then goes through that point and then
It doesn't hit, it goes through, it passes through this point.
yeah, but how do you know it passed through on the second half of the journey, not the first half?
It could easily be on the first half of the journey as well. I might have drawn the sketch wrong. I could have drawn the sketch wrong as well. Although I can't really imagine how it could be on the first half with two angles.
No,
Can't see that.
If one, on the second half of it, that was a steep one, and then the first half of it was a shallow one.
Yes, it could work like that. No, I think it's always going to be on the second half. It could be like, if it was like that, it would then have to be like that. So it would be the first half of the journey for that one, but the second half of the journey for that one. Okay, hang on, guys, because I want to tell you some things you're going to need to do. Oh, is this the same question? Yeah. Oh, great, we did finish it. So, hang on. These are then a summary that they give you in the textbook. You do not need to know these by heart. It would be crazy to know them by heart, but you do need to be able to find out how to calculate all of these kinds of things and how to prove them, right? I haven't seen it come up in an exam yet, so why not you? Why not you be the first year? So I'm going to give you some questions on that, and hang on, hold up. I don't like this when you do that bit where you will pack up. You're going to have to do some questions on projectiles from the exam booklet as well. There are only 3 of them to have a look at. Maybe you won't do the vectors one. I don't know, you could do the vectors one. Okay, guys. See you later.